Hello again, everyone. I hope you're doing well. This video will discuss one example of converting equations from polar form to rectangular form. Okay, and so using that process there, just to remind you of the things that we use to do this, these three equations here, x equals r cosine, y equals r sine theta, and r squared equals x squared plus y squared, those equations are the ones that we used to convert polar coordinates to rectangular coordinates, or vice versa, rectangular coordinates to polar coordinates. And we also had another one there about theta, but we won't be using that for the equations. But these three equations are what we're going to use, along with a couple of other tricks maybe, to convert the equations from one form to another. So let's take a look at an example here. R equals 4 cosine theta. And you take a look at that, and you see r by itself, you see 4 cosine theta. Not quite exactly ready to use these equations yet, but it looks like the two that we might use would be those two. And this process really is about direct substitution. So if I had an r squared, I would just substitute it with x squared plus y squared. Or if I had an r cosine theta, I would just replace that or substitute it with x. So we don't have that yet, but here I'll show you a little trick. It's easy enough to do. All you have to do is multiply both sides of the equation by r. And when you do that, all right, when you do that, you can see on the left side, you'll have r squared. On the right side, you'll see 4r cosine theta. So that's just kind of moving that r there in between the 4 and the cosine, so we have r cosine. So on the left, we can replace that with x squared plus y squared. There we are. It's done. On the right, you see that we do have this r cosine there, which will be replaced, I should say, with x, and so that equals 4x. And you know what? We're pretty much done right there. About the only other thing you might want to do is rewrite it so that it's set equal to 0, a little bit more standard form there for the equation of a circle, which is what that is. And that's it. We're done. Okay, wasn't that fun? Hi again, hope you're doing well still. This is another example of changing a polar equation to a rectangular equation. And once again, we will use the three conversion equations over there in the red box. Okay, so let's have a look at one. This one's going to be a little bit more involved than the other one, although that doesn't look so bad, does it? R equals 3 plus sine 2 theta. Looks like a fairly simple equation. Now, last time our first step last time was to multiply everything by r, and that gave us the r squared that we wanted to use. It gave us an r cosine before, or anyway, we can use those all three of those equations there in the red box. So let's try that, see what happens. When I multiply everything by r, what I get is r squared on the left equals 3r plus r sine 2 theta. Well, okay, sort of good. I got the x squared plus y squared possibility over there on the left-hand side of the equation, but I'm not really sure what to do with this 3r and the r sine 2 theta. I would rather have an r squared than an r, right? So let's try doing this again. Let's multiply everything again by r and see what happens this time. I'll get r cubed equals 3r squared plus r squared sine 2 theta. Now, okay, I'm not really sure that was much better. I've got an r cubed over there on the left side, which is a little bit awkward, but I do have 3r squared. Okay, I could replace the r squared with x squared plus y squared. Then I've got this r squared sine 2 theta thing. I still don't have a r sine theta. That 2 is kind of messing it up. So let's deal with sine 2 theta. Remember, sine 2 theta is equal to 2 sine theta cosine theta. So if I just replace the sine 2 theta with 2 sine theta cosine theta, like I just said, my right side of the equation now is 3r squared plus r squared. Now, I still don't see an r sine or an r cosine, but let me show you a little twist here to this. See what happens here. See if you can pick out what happened. Can you figure that out? Did you see what happened? I've now got 2r sine theta, r cosine theta, instead of r squared times all of that. It's almost like I distributed the r squared. One of them went right there, and the other one went over there. It's still r times r, so it's r squared, but it's now written out in this other form. And this is great, because now I've got r sine theta, that equals y, and r cosine theta, which equals x. So the right-hand side of this equation now turns out to be 3 times x squared plus y squared plus 2xy. Fabulous, okay? Now I've still, unfortunately, got this r cubed on the left-hand side of the equation to deal with. That is a little bit awkward, so let's think about that for a second. R cubed, of course, equals r times r squared. Okay, well I could replace the r squared with x squared plus y squared. So let's do that. R times the sum of x squared plus y squared. Now I still have r though. I'm not quite done. Now if you think about that last equation in the red box there, the one we've been using a lot this time, r, if I solved it for r, I'd get this, the square root of x squared plus y squared. So that's what I'm going to use. Awkward though it may be, I'm going to replace the r with the square root of x squared plus y squared. And so now r cubed equals the square root of x squared plus y squared times the sum of x squared plus y squared. So there it is. I've got everything in the equation now changed into x's and y's. No more r's, no more thetas, so we're done. We've changed it from polar form into rectangular form. Whew, it took a long time. Let's write out the final deal there. R cubed, that's the right-hand side there. This is what it all looks like. A great big rectangular equation, and boy, if that was your job to graph that thing, you would be in for a bit of work now, wouldn't you? Trying to figure out what that looks like, you just have to start plugging in numbers for x and y and squaring and square rooting and all this stuff. You'd have a big mess on your hands, I'll tell you. Wouldn't it be much simpler to just graph r equals 3 plus sine 2 theta? Oh yes, indeedy, it sure would. All you'd have to do is pick some numbers for theta, figure out the sine of 2 times those numbers, add 3, and there you've got r. Do that a few more times, and you've got probably enough points to start sketching a graph of that polar equation. Just in case you want to know what it looks like, there it is. That's what the graph looks like. Okay? So it's kind of a simple, sort of humble-looking graph, and it's kind of a humble equation. I think the polar equation does a much better job for that graph than the rectangular form. Anyway, hope you enjoyed that. Bye-bye.